Fabrication by 3D printing is known to be time-consuming and costly, especially for printing high-fidelity and large objects. We present a new approach for cost-effective 3D fabrication using universal building blocks and pyramidal shells. Our key idea is to employ a set of universal building blocks which can be massively prefabricated to assemble a significant internal core of the input object. Then, only the outer portion or the residual volume needs to be 3D printed online. Such residual is further decomposed into a small number of printing-friendly pyramidal pieces. This way, we can significantly reduce the overall 3D fabrication cost and time. Hence, given a 3D object, our objective is to find a large internal core which would allow efficient 3D printing of the residual. We adopt a pyramidal decomposition to print the residual, due to its efficiency for FDM-based 3D printing. Our objective function minimizes a sum of three terms: V, the volume of the residual, N, number of pyramidal residual pieces, and W, waste material for printing these pieces. Our universal building blocks consist of the cube and a few slanted pieces. There are only 2 kinds in 2D and 4 kinds in 3D, but they can be manufactured at different scales. To best illustrate our algorithm, we use a 2D example. In the first step, to find a grid layout for the universal building blocks, we grow a set of maximal cuboids inside the input shape through a randomized search. Then, we choose an orientation with which we can enclose the maximum number of full grid cells in the shape. These enclosed grid cells, together with the slanted pieces, form an initial guess for the internal core that minimizes V. But N and W are suboptimal. To minimize N and W, we need to coarsify the initial internal core by performing local cuts. As shown here, these cuts would help reduce the number of pyramidal residual parts, and the support waste material in the printing. In the end, we fit universal building blocks of larger scale in the internal core, and assemble them with the pyramidal residual parts to reproduce the whole object. Here is a sequence showing our algorithm at work for a 3D sofa model. More technical details can be found in the paper. At the end, we print the pyramidal residual parts and use blue tack to glue them onto the internal core, assembled from the universal building blocks. Here are more results of our decomposition algorithm, and the saving on total 3D printing time and cost. Thank you.